Okay, boys and girls, here's our next step is chapter 9, differential equations. Um, so we have differential equations and we might want to find our original equation using integration, or we might like to verify that something is a solution. So this is the first thing we're doing, is verifying solutions of a differential equation. To see if it's a valid solution to the dE, we need to substitute it into it and show that left-hand side equals the right-hand side. So here I have first one, dy dx equals 3x squared minus 12x, and then plus 12, y equals x minus 2 cubed. Okay, so we just want to find dy dx. Still a bit thick. We get 3 times the derivative of x minus 2, which is 1, which is then x minus 2 squared, i.e. the chain rule, 3 x minus 2 squared, which is equal to 3 x squared minus 4x plus 4, which is 3 x squared minus 12x plus 12. Therefore, left-hand side equals right-hand side. We've proven that if I was, here we could say 3x squared minus 12x plus 12, i.e. this is equal to 3x squared minus 12x plus 12, so left-hand side is equal to right-hand side, so we've proven it. Okay, next one, 4y, y double dash equals 3x. So we have what y is, we need to find y double dash. So y dash is going to be, derive that and leave that alone, so it's going to be root x, because that's going to be 1, plus derive root x, which is 1 on 2 root x, multiplied by x, so that's our first derivative, but we know we can clean that up, root x, plus, if I have that x on top, it's going to be root x, that's not an x, on 2, because if we have x over root x, that's the same as x over x to the 1/2. That's a 1. When we subtract the powers, we get x to the half, which is root x. So I get root x plus root x on 2, which is 3 root x on 2. Okay, then we've got to double diff it, y double dash. Okay, when we derive this one, it's nice and easy. That was also 3x to the half on 2. So when we derive it, we're going to get 3 on 4, x to the negative a half, which is 3 on 4 root x. So from here, therefore, 4y, y double dash is equal to 4 x root x times 3 on 4 root x, which is 12 x root x on 4 root x, which is 3x. So therefore, LHS equals RHS, and we've proven that 4y dash, y double dash, 4y, y double dash is equal to 3x. Okay, find the values of k if y equals e to the kx satisfies this equation. So we know we've got y equals e to the kx. So let's put that here. So we know that dy dx is going to be ke to the kx, and d squared y dx squared is equal to k squared e to the kx. So we can sub all of that into the equation. K squared e to the kx minus 4e to the kx minus 5, oops, I forgot here, dy dx, I forgot my k, that k, ke to the kx minus 5e to the kx equals 0. E to the kx we can take out as a common factor. So we're going to end up with k squared minus 4k minus 5 equals 0. E to the kx can never equal 0, as e to the x is either greater than 0 or e to the negative x is always less than 0 for all x. So it doesn't matter what k is. If k is negative, it's going to be less than 0. If k is positive, it's going to be greater than 0. So then we solve this. K minus 5, k minus plus 1 equals 0, k equals 5 or negative 1. So if k equals 5 or negative 1, it will satisfy this equation. There's no values of k that wouldn't satisfy it, like wouldn't make it correct, so it can be either negative 5 or 1. Okay, find the constants, not constraints. Find the constants a and b such that that's a solution to the differential equation. A little bit more annoying because we've got to go through and first work out dy dx. Okay, so dy dx, let's derive this. 4e to the 4x times 2x plus 1. And let's derive this. 2e to the 4x. So that's my first derivative. You can take out 2e to the 2x. 4x. Okay, so we would have a 2 here times 2x, 4x. A 2 here times 1, which is plus 2. And then I've taken all of that out, so I'm left with a plus 1. So I'd end up with 2e to the 4x, 4x plus 3. Okay, so that's our first derivative. Our second derivative, d squared y dx squared, is, let's derive this, 8e to the 4x. Leave this alone, 4x plus 3. Derive this, 4. Leave this alone, 2e to the 4x, which is, okay, we've got 8e to the 4x we can take out as a common factor, because that's 8e to the 4x. We're left with 4x plus 3 plus another 1 plus 4, which of course we could take a 4 out as a common factor. So 32e to the 4x, x plus 1. Okay, find the constants a and b. That's a solution. So we can sub in 32e to the 4x, got my x up there, x plus 1 minus a times dy dx, 2e to the 4x, 4x plus 3, and then minus b times e to the 4x, 2x plus 1 equals 0. Okay, what's common to all these? The e to the 4x's. So e to the 4x, scrap it there, scrap it there, scrap it there. Okay, so I'm going to get 32x plus 32 minus a times 2 times 4x, so 8ax, a times 2 times 3, negative 6a, so that's that done, minus 2bx, and then minus b equals 0. Okay, so what can we say here? We can get all of that. Well, we've got e to the 4x, so we know that's going to have no solution. as e to the 4x is greater than 0 for all x. Here, let's group together our a terms. Okay, so here if we group together our a terms, what are we going to get? We're going to get negative 8x minus 6a. So that's that and that's that. And let's group together our b terms. So negative 2b minus b, and then that is, what am I doing? Negative 2x, and then minus 1b. So that's that taken care of and that taken care of. And no, we need to get it in terms of x's. What am I thinking? Because then we can equate coefficients. Okay, so from here, all of our x's, 32x, negative 8x, negative 2bx. So 32 minus 8a minus 2b x. That's that done, that done, that done. Plus 32 minus 6a. And then, what am I going to have? Minus b equals 0. Okay, so from this equation, we're going to have 8a plus 2b equals 32, because if I equate that equal to 0 and then bring these to the other side, the other one, I'm going to have 6a plus b is equal to 32. They're both equal to 32. Okay, if we divide the top one by 2, we're going to get 4a plus b equals 16. So 1, 2, 3. If we do 2, take away 3, we're going to get 2a equals 16. So a equals 8. Then if we do sub a equals 8 into the bottom one, we get 4 times 8 plus b equals 16. So b equals, that's 32. When we subtract 32, we get b equals negative 16. So if a equals 8 and b equals negative 16, this equation, this is a solution to this equation. This equation when a equals 8 and b equals negative 16. Okay, let's just quickly have a look and make sure I didn't stuff anything up. So I should be able to find my solution somewhere. Spesh methods.com spesh solutions. Of course, I have to put in the password. Whose stupid idea was that? Zebra, you paying attention? No? Okay. Alright, let's have a look. Differential equations and password again. Okay, 5, negative 1. So a equals 8b. Did I forget to subtract? 8a plus 2b equals 32. So somehow back here, I got a plus 2b. Because that's a plus that. Oh, maybe I stuffed it up here. That's supposed to be a plus. So in here, that's supposed to be a plus. I didn't know that before I went through the question. So if that is a plus, that's going to change this value It's going to change a couple of the values. When it's a plus, it won't be that different. But yeah, obviously I've stuffed it up because of the wrong equation to start off with. But you get the idea. So when it says you've got to verify a solution, you have to substitute it, find the information. So here we've got to find that derivative and show that they're the same. Here we've got y, we need to find y double dash. Here we've got y, but we need to show that it's something that satisfies this solution. So I've got to derive it once and sub it in, and then derive it twice and sub it in, and then solve to find out which values make that equation correct. And likewise here for the solution of this second order differential equation, we've got to find our two derivatives. Try and simplify them first, like I did. If you make them big and then substitute in, it makes it really hard to do. So always try and simplify it first. And good luck.